Hi guys, so I'm sorry I can't be there today, but I went ahead and made this little short video to go over our lesson so that we wouldn't be behind very much and we would have Tuesday when I come back to discuss this stuff. Hopefully when I come back, it'll be a little bit clearer and we won't have as many questions. So when you leave today, this is kind of the last section before we wrap up everything and start reviewing for our test on Thursday. Dilations are when you change the size of the object, meaning like we can shrink it, we can compress it, which is the same thing as shrinking. Basically, making it change in size is what a dilation is. Think about getting your eyes dilated. They put the stuff in there and your pupils get larger. There are dilations all around my classroom. Like when you see the big giant pencil, that's a dilation because it's a huge scale factor change to a real life object. When you look at billboards, those are dilations. When you look at a physical picture, like the 3x5 or a 4x6 that you hold in your hand, all those are dilations. So we're going to specifically focus on a couple, and that's a vertical stretch and a vertical compression. So imagine like you have a pop can sitting on your desk and you smash it. So what's going to happen is that pop can, when it goes down, gets wider. Okay, that would be a vertical compression because you took something and you shortened it, and that's going to make it go wider. In this case, that happens when we have a multiplier out in front where the number is less than 1. So like, let's pretend it's like a 1/2 or a 1/4 or a 1/3. Anything that represents a number smaller than 1 is going to make it shorter. And that's what a vertical compression is. Okay. Then we have a vertical stretch. So when that multiplier number out there is bigger than 1, it's going to stretch the object. Imagine something that like a spring or a slinky that's standing up. If that slinky is standing or sitting on your desk right now and you take it and you pull it upward, it's going to stretch everything and make it taller. All right. We're going to focus out of all of our parent functions, the 3 that we have, we're going to do dilations only with this one, y equals the absolute value of x. And the reason that we're going to do that is pretty much because y equals absolute value of x has a really nice pattern, that over 1 up 1 pattern. That's going to allow us to work easily with some vertical stretches and compressions. Okay, so here we have, like in front of the absolute value for the first one, you have a 3. Since 3 is bigger than 1 up here that we talked about, as long as that number is bigger than 1, then you're going to have something that stretches your object out. Now, let me just for the sake of reference, go back and draw in our normal absolute value. So it's going to go over 1, up 1. So this one right here that I'm drawing with the yellow highlighter, that's our normal y equals absolute value function. But this guy that we're working with right now, this one's going to be a vertical stretch. Whoa, what just happened to my graph? It's moving. By 3, meaning it's going to get 3 times taller. Okay, let's try to put this thing back. All right. So if our normal pattern is over 1, up 1, our pattern for this one's still going to go over 1. We're going to keep that where it's always going right 1 or left 1. But we're going to go, instead of up 1, we're going to go up 3. So in green here, we haven't moved anything left or right. So our normal main point is still at 0, 0. And then we're going to go over 1, up 1, 2, 3, put our dot. Then move over 1 from there and go up 1, 2, 3 again. And over 1, up 3. And so you get lots of points to be able to make that right side. And then go back and do the same with the left. You're going to go left 1, up 3. Then left 1, up 3. Left 1, up 3. To where you get the mirror image. And now when we connect those, see if I can get a nice line in here. When we connect those dots, you can see how this one compares to the other ones. Definitely much taller and skinnier. Okay. I know this is supposed to be a 4 down here. So since this number, the 1/4 that's multiplying out in front, is definitely less than 1, we see that that has to be a vertical compression. So we're going to write out what's happening. So write down your description like we have been. Whoops, how about vertical compression by 1/4, meaning you're all of a sudden going to chop off the height of this 1/4. So imagine, if you look at the graph that's already on the left, if you imagine the yellow one, the original, if you take your hand and you just smash it down, that's what this is going to look like. So if I smash that down, all those points drop and they get lower, and that's going to make my graph kind of look fatter, so to speak. So we're still going to move over 1. That's always our job. But instead of moving up 1, we're only going to be able to move up 1/4 of a step at a time. So I'm going to start with my original point at 0, 0. And then here's where you have to be very careful, because if I go over 1, I can barely move up any by moving up 1/4. And then you're going to go over 1, up 1/4, over 1, up 1/4. So it takes me 4 full steps to the right to be able to get to that first dot. Okay, so you can see, oh, my dots just disappeared. You can see that this thing's going to definitely be really flat looking. So now I'm going to go left 1, up 1/4, left 1, up 1/4, left 1, up 1/4, and left 1, up 1/4. So when I connect these, holy, you guys might want to try to use like your ID or something straight to connect these dots, so that looks prettier than mine. Okay, I definitely want to see points when I see your papers. So that one you can see, compare it to the yellow one on the left, and you can tell that's definitely much flatter in comparison. All right, so looking at number 3, now we have more moves going on. So like we were doing the other day, we're going to figure out what each one of these does. We're going to write down their descriptions. Okay, so the first one, that was a 3 that I just drew. The first move is that x minus 2. So we know that that's going to move it right 2. Okay, then my second thing that I'm going to see is that 1/2 out in front. That means that there is a vertical compression. Sorry, it's hard to write with this marker. By 1/2. And then last but not least, I'm going to go up 3. So I can combine these 2 steps right at the beginning to move my main point. So it says right 2, up 3. So I'm going to take this, I'm going to go right 2 spaces, up 3 spaces to start my graph. So there's my first main point. Now, from there is when I'm going to have to do my pattern that applies my vertical compression. So remember what we just did on the last 2. So since it's a vertical compression of 1/2, that means that I'm going to go over 1, up 1/2 of a step, over 1, up 1/2 of a step, and over 1, up 1/2, and I'm out of spaces to keep going to the right. Go back to your main point and go left, left, up 1/2, left, up 1/2, left, up 1/2. And I would do that till I have several that I can connect. And then draw your line. Okay, so that's what that one looks like. Now, on the last time I saw you on Thursday, some people were really bothered by like the graph looking like it was bigger on one side than the other. That's because we have more room on the left to draw it than we do on the right. So just deal with that. You'll be fine. Okay. On number 4, we have lots of things going on. So we have this first move, which is going to move it to the left 1 space. Then I have the second and third are kind of attached to one another. But one thing that you have to pay attention to is that that 4 and that negative are 2 different moves when it comes to this. So the second move is going to vertically stretch it. And it's going to make it 4 times taller. So that's going to be over 1, up 4. And then the negative is going to flip it over the x-axis. So all my up moves just became down moves. And then last but not least is this little -4 that's hanging out down here. And that's going to move it down down 3 spaces. I think I said 4. Okay, down 3 spaces. So we're going to combine those first 2 moves right here to get our new starting point. Okay, so let's go ahead and try that. Left 1, down 3. Give myself some room. Left 1, down 3. Put your starting dot. Okay. Now our normal pattern would be over 1, up 1, over 1, up 1 for absolute value, But now we have to go over 1 and then 4 vertical spaces because of the vertical stretch. But ups become downs because of the over X. So I'm going to go right 1, down 4, put a dot. Right 1, down 1, 2, 3, 4, put a dot. See if I have more room. 1, 2, 3, 4. So I have room to get 3 more points. And go back to my main point and do it on the left side. So left 1, down 4. Left 1, down 4. And some of you, I think, have caught on and you just mirror image what's on the right side, which is totally fine. And draw your absolute value. Okay, so that should give you a little bit of an understanding of how the dilations work. Remember that that number that's multiplying out in front tells you how much you're allowed to move up or down every time you take a step to the right or the left. So for every 1 step horizontally, let's see if my marker will change. It's not. For every 1 step horizontally, that tells you how much you can go vertically. Okay, so this video is going to be on your Google Classroom if it's being played in class. So you can always refer to it and you can come back and listen to it. But at this point, you need to start doing the practice paper so that you can try to get this all done. Okay, when I come back, if you have any questions, you just let me know and we'll talk about them then. If you need to text me, that's fine too. I'll be around. Thanks.